Hey folks, we're going to get started in about 2 minutes here, so just hang tight. All right, cool. Let's get going. So I'm going to do another Code Wars stream again today. Feeling like these are working for now, at least, just as an experiment, kind of. So, real quick before we start, I'm just going to kind of go over the spiel and give a like introduction of what I'm doing, just in case you're new. So this is Study Hall. This is a place for you all to bring your questions, and if you have any questions, regarding Python, you can bring them and let me know. The link and learn. Send in the link and learn. Excuse me, into Slack, and I'll be able to find it quicker. And if you have any code you want me to troubleshoot, you're welcome to send that in as well. It doesn't have to be from Learn. It can be a problem from Code Wars or any other problem from anywhere, just so long as I have a clear problem statement. And if you want me to, like I said, if you want me to debug any code, feel free to share that. Also, if you just want me to go cover a concept, I'm happy to do that as well. Cool. So since I'm not seeing any questions as of yet, I'm just going to go through and solve some Code Wars problems. And again, the purpose of this is just to really just talk about the purpose of what I mean. The purpose of doing the Code Wars streams is just to really talk about like workflow stuff and kind of look at a more realistic problem, real-ish. I mean, it's still in sort of the vacuum of happening in Code Wars, but it's like you get a little problem statement, a little story with it, so you get to kind of work something out. And sometimes they can be a little messy. These problems can be a little messy, but sometimes untangling that mess is kind of part of the fun and part of the learning of it as well. So, yeah, I think that messiness is kind of okay, and I'll kind of talk about ways that I kind of deal with that and kind of like suss out a clear example. Cool. So this is Code Wars. This is like kind of the landing page after you create an account and log in. This is sort of the place where it'll take you. So what I like to do is, I mean, you can just do like whatever your next challenge. Do whichever one comes up that you want to do. But what I like to do is I'll come down here to kata, which is the magnifying glass icon. And then you make sure that Python is selected. I realized you can't see it's funny. I'm clicking here, and I believe the drop-down menu isn't showing up. Yeah, it's funny. The drop-down menu isn't showing up in the OBS stream, so I'm not sure what's with that. But anyways, I did click here, and I get a drop-down menu of languages. So I'll scroll down to Python. There's a whole bunch here. So there's Python. Make sure I'm only getting Python questions. And then, you probably won't have to do that, but you might. Oops, let's do that. There we go. And then the important thing is just select the difficulty that you want to do. So for those of you who don't know, maybe you're new to Code Wars or something, the 1s and 2s are very difficult. They are seriously challenging problems. The 8s, I think, are very bite-sized. They're very beginner-friendly. So you can select just whichever difficulty that you want. If I want to do 3s, I'll just click on 3, whatever. But I can select a range of difficulties. So I'll select 8s through 6s here. And then from here, there's no real science to it. Just look for a problem that looks fun and go from there. So yeah. Cool. So I'll just look through here, and then I keep seeing this one, gravity flip, right here. So let's just do gravity flip. This should be fairly straightforward. I thought, whoa, did I do this one? I thought I did this one. Huh. Okay. Gosh, I really thought I did this one on stream, but it says I didn't do it. Maybe I was logged into my other account. I'm gonna do it again. Okay, cool. So I've got my problem here. So what you're looking at on the left, you've got your problem statement. This also doubles as your output window for when you run your code and you get an output here. Now this really isn't a proper terminal. It'll show you the output of the tests that were run here or behind the scenes. When you click submit, when you go to actually submit your code, it'll run other tests that aren't shown here. So it could potentially run a whole bunch of tests. And then your the output of those tests, whether they succeeded or failed, and any, if they failed, any error that the author of this challenge chose to include will be shown here in the output area. But like I said, this isn't really a proper terminal. So for that reason, I prefer not to, and I highly, highly recommend that you don't do your work out of this environment. When you go to do the work, like actually solve the problem, move over to Replit, or if you don't have an environment set up yet, you can do it in Replit. That's fine for now at least. But I have my editor here. You can use VS Code in the same way that I'm going to be using my editor here. And it'll all be the same. So just so long as you have like a full REPL environment, read, evaluate, print loop. To me, what that looks like is, a proper editor and a proper terminal like this. So that's what I'm looking for in an environment. So first thing I like to do is, oops. We'll copy the problem statement. Oh my gosh, I definitely did this problem recently. Whatever. I'm doing it again. Okay, so I'll copy in the problem statement, and I'll just keep this here for now. And I like to copy it in, and I always kind of recommend that you do that because it makes yeah, it kind of makes understanding it, if there's some sometimes you need to kind of like rewrite it a little to like get a clear idea. So I can like take notes. I can kind of restructure this in a way that's more familiar or more structured. So that's why I like to have it on site. And I'm also going to kind of look through here and make tests, and I'll make tests out of these here. Cool. So I'll bring in the problem statement, and then I'll also bring in the tests. So my first goal, and I haven't even read the problem statement yet this time. So my first goal is just to write some tests. Even before I read the problem statement all the way through, I like to get a few tests down. So I know that this function is called flip, right? So, sorry, let me back this up a little bit. So these are the tests as I pasted them in, as I copied them from Code Wars. And really what I'm looking for is any line that makes a call to my function. So my function is called flip. And if I go look, here's all the flips, right? So those are the only lines that I'm interested in this case. So all the other lines, I'm just going to get rid of those. We don't need those for now. Just look for any line that's calling the function that you're going to write. And then pretty simple from here, what we're going to do is we're going to print it out. And then in these cases, so basically what I'm doing here, these tests, all that I need to write these tests is an expectation. I need to know what to expect for a given input into this function, right? So I'll kind of talk about that. Oops. Okay. This is not going to work. Okay, that's going to work. So this is going to be my expectation. It's going to equal this. And this is going to be my result. It's going to equal that. And then, oops, we'll do that. We'll do that. And we'll do that. Okay. Whoops. Sorry. That's better. Okay. So I've got my result that I'm capturing here. I've got what I expect for this function call. And in here, what I like to do is just say res equals exp. And since I'm using a double equals, this is going to give me true or false. So that'll tell me, if it's true, that'll tell me that my result matches my expectation, which means the the test is passing, right? And in the case the test fails, I also want to see the result to see if it's failing, how it's failing, right? So if I didn't get what I expected, what did I get? So I always do this thing, res equals exp, and then res, so I can see the result. So yeah, so this is all I need to make tests. And you can see I just have a call to my function, and I have these inputs. So what I'm saying is, given this specific set of inputs, given these two inputs into the function, I expect the function to return this result. So given that I know what this is supposed to do, I expect it to do this. And then I'm just going to print this off. Tells me true or false, whether it's passing the test or not, and then shows me the actual result that I got, so I can visually verify that yes, it is indeed passing, or no, it's not passing. And if it's not passing, I can see how it's not passing and why it's not passing. Cool. So from here, I'm just going to stub out my function, def flip pass. Okay. And let's just run everything, make sure we don't have any weird syntax errors. Oh yeah, of course. Let's just do this for now, A and B. Good, false and none. That's what we expect. Okay, so now we can read the problem statement. Oh yeah, and I forgot. I'll usually look through the problem statement. A lot of them will have examples given. So I'll just grab the examples and do the same thing here. Let me just do that real quick. And I want to see 3, 2, 1, 2, 3, 2, 1, 2. So this one's the same. And then 1, 4, 5, 3, 5. Okay, these are actually both the same as the actual tests. So that's kind of nice. Makes it easy. Okay, now we can read the problem statement. Okay, so this is for something else. Okay. So this says Bob is bored during his physics lesson, so he's built himself a toy box to help him pass the time. The box is special because it has the ability to change gravity. There are some columns of toy cubes in the box arranged in a line. The ith column contains AI cubes. So here we have columns. So we got 1, 2, 3, 4 columns, I guess. Contains AI cubes. So we're counting columns, or we're counting the cubes in each column. Okay. So at first, okay. At first, the gravity in the box is pulling the cubes downwards. When Bob switches the gravity, it begins to pull the cubes to a certain side of the box. D. Okay. So the side of the box can either be left or right. Below is an example of what the box of cubes might look like before and after switching the gravity. Okay, so if we start, it's saying, here's our box of cubes on the left. Oops. Left. And if we switch it to leaning to the right, to the gravity pulling it to the right, it's going to look like this. Cool. So given an initial configuration of the cubes in the box, find out how many cubes are at each of the n columns after Bob switches the gravity. Cool. All right, so I'm just looking here real quick. Oh, shoot. That is my code. That's so funny. I wonder why it didn't say this one was finished, because this is my code from last time. I didn't even notice that. Yeah, so we're going to take in D, which is for direction, and then A, which is going to be for array. So in this case, I'll just pretend like I didn't see my solution there. Usually they'll just have like a little function stub here that'll just be like pass or something like that. Yeah. So D will be our direction. So you can see that our first argument is a direction left or right, and then our second argument is the actual array, right? So this array, or this list, an array is just another name for a list. So this list describes the number of cubes in each column. If you look at this one, right? So this has 3 cubes, then 2 cubes, and then 1 cube, and then 2 cubes again. So that's 3, 2, 1, 2, and that's actually what we're testing here. And we shift from left to right, and so that's this test. So the one pictured is the one we're actually testing for, which is nice. We don't always have that kind of parity in these problems. Um, so then the expectation is that we should get a 1, 2, 2, 3s, right? So we should have the first column should have 1, and then 2, and then 2, and then 3. So basically, one thing that I notice in any version where we tilt left or right, there's going to be an ordering to the sorting, basically, right? So regardless of if the, like if there's like a wavering, there's more and then there's less and then there's more and then there's less. Once we lean it, I'm thinking about leaning it in one direction or another, because that's the way that I can conceive of a box changing gravity, is just the box changing its orientation in gravity, right? So if I lean it to the right, it's going to, the number of boxes in each column is going to ascend, right? It's going to go from smallest to largest. Whereas if I lean it to the left, it's going to organize all the elements in descending order. So if we, so basically that's the point that I'm going to make. So it occurs to me that sorting this array is going to be useful in some way, right? So if I do, and what I have here, you can just see I have sorted A, and then I just reverse it. And maybe that didn't work. Yeah, I was like, there's no way that worked. So it looks like I started this one and then didn't finish it from before. So cool. So let's do, but I do know I am going to have to sort it, and depending on whether it's left or right is going to tell me whether it has to be in ascending order or descending order. So yeah. So we could do sorted, and I'm just going to return this. Return sorted. Return sorted A. Like this. Okay. So we do have one of them passing. It will pass in that example. And then my guess here is that if I just do this, then that passes in the other example, right? So it looks like my guess is based on whether it's it's sorting left or right, whether I'm leaning left or right is going to tell me whether I should reverse it or not. So it looks like left passes when I reverse and right passes when I don't reverse. So I'm thinking about this. I could do, I wonder if I do this. A slice cannot be in steps of 0. Okay. That's what I was thinking. I don't think I've ever actually got that error before. I tried that and I was like, I don't think this is going to work, but just in case, I had a trick up my sleeve to do if that was the case, but that's all right. So let's see here. If I could, I could just put a ternary right here. I think that's what I'll do. So I'll say -1 if D equals L, else 1. Let's just try that. And that'll pass both of them. Cool. So this is just a fun little trick you can do for if you want to get it all on one line. This is a way of turning an if-else into kind of a one-liner. But basically, this is a ternary in Python, a ternary statement. A ternary just means that you do one thing if some condition is true, otherwise you do the other thing. So in this case, here's our condition. If the condition is true, we do the first thing. If it's false, we return the other thing. So a ternary, it's important to note that a ternary always returns a value, basically. So it either returns the first part or the last part. Interestingly, if you want to check another condition and kind of make it an if, else, the else clause can be another ternary, right? So I could have a, else this if some other condition, else some other condition, right? So with a ternary, you do have to have an else. So you can't just have just an if, and there is no, formally there is no elif as such. Like I said, if you want to have an elif, you just do else second consequent if second condition is true, else other consequent. Cool. So that's a ternary, but I could rewrite this in a simpler way. I could just do, let's do this. I could say with -1. Oops. So if it's L, we're gonna reverse it. Else, we're going to not reverse it and just sort it. So that's the same either way. So that ternary way of doing things is logically identical to this way of doing things, but I'm gonna do it the other way because it's kind of nice and clean, and the Code Wars ethos, for better or for worse, for better or for worse, is to get everything on one line, which is, it's a fun challenge, like as a fun coding challenge. I kind of like it, but as like a realistic day-to-day programming thing, you don't have to get everything on one line. It's just, I think about it as just for fun, kind of. Cool. So I'll submit that. Looks like that worked, and you can see this is going to be similar code. Yeah. Oh, I just remembered this, right? Oh, sorted has a reversed flag. So that's actually a really cool thing we could do for this. I should have thought of that. So we could do sorted reversed equals. So we have to pass this as a keyword argument, I believe. And then reversed equals, this will be D equals L, like that. Yeah. I think that's it. So if D equals L, so if this condition is true, then that's going to evaluate as true, and then reverse will equal true. Otherwise, this will be false. Yeah. So reverse will be false. Oh, is it? It's just reverse, isn't it? Yeah. So that's also passing. That's even nicer. I'm going to resubmit this. I like that code even more. Attempt. Okay, there we go. Now I'm happy. Sweet. Okay, cool. And then, yeah, obviously you can just look through here and, just find different ways of people doing this. This person's taking multiple steps, which is cool. I mean, they're getting it done, and each each line's a very nice, discrete step, you know. Here's another ternary somebody's using. They're doing a whole reverse equals true. So they're using the ternary in a different place than I did. I used mine in the middle of a slice I was using slicing to reverse the list or not. Oops. And then, this is using the ternary to determine the whole return. Either return, sorted A if D equals R, else sorted A reverse equals true. So, and then this final solution is basically I took this condition here and just put it in this reverse equals true or false, since reverse just takes a Boolean. It just need to give it the right condition so that it's true when it needs to be true. And it looks like, this is basically the same thing. Somebody's using a lambda here. Kudos for that. Cool. Yeah, so you can see there's a lot of solutions. Like I said, it's always good to look through, and you can get a lot of good ideas about how to do things that way. Awesome. Okay. I'm not seeing any questions just yet. Do feel free to ask any questions if you've got them. Yeah. I think I might want to switch gears here a little bit. I think what I'll do is maybe switch to our material a little bit and start going through some of that. Let me find the cohort that I was in. Okay. Need to find it in here. Shoot, I changed some settings in this in my browser here, and I kind of lost my previous ones, or my previous tabs that I had open. So let me just, it's 2020. Oh my gosh, I've got so many here. This appears to be the one. Okay. Cool. Sorry about that. Let's just jump into it. So, all right. kind of do this here, make that a little bit cleaner. Okay. So we're going to jump in. We're going to switch gears going into our own material here at Galvanize. We're in the importing section. And we'll talk about importing the math module. So by the end of this lesson, you'll be able to use the math module to import the square root and factorial methods. Gosh, excuse me. I always get hiccups. At some point during stream, of course. All right. So, importing math. So we can, Python has what's called a standard library, which is, basically this is a model for every language at this point, to have a standard library of various tools that are built into the language. They're just given for free with the language. So there are some of those tools are just included by default. You don't have to do anything to bring them in, and some of those tools are not included. You have to bring them in, but they're available. You don't have to install anything special. They're part of the standard installation, right? So the math module is part of any standard Python installation will have a math module, but it's not imported by default. So it's not, I can't just start using stuff for math without explicitly bringing in the math module. So to do that, I'll just say import math. And there's a few different forms of this. If you're new to importing modules, I recommend you just start with this. This is the simplest form. Kind of gives you the least to worry about, the least to think about. So just start with import and then the name of the module. I'll cover some of the other forms. If I wanted to, let's say I wanted to do square root, right? So I wanted to bring in the math.sqrt function. We'll do the square root of 16, which is 4. Okay, so math.square root of 16 is 4. So if I try to do this without, here, I'll just comment that out. So if I try to run math.square root without importing math, we're going to get an error. It says name error, name math is not defined. And even though math is part of the standard library, I can't just use it because I didn't import it, right? If I try to use square root, same thing. Name square root is not defined. So if I want to use math.square root, I have to import math. But now, what this does, what line 35 here does, the import line, is it brings the whole math module into the program's scope. It loads in the whole module. Basically, it loads in the whole module into memory. Which, like I said, this is what you should use for now, at least. If there's, like if you're new to this, if you're a beginner, if you want to, I want to cover this other way, just in case you're more intermediate, or if you're, I'm covering this other way because you'll see it this way, and just want you to know kind of what you're seeing. So the other way to import something is I can say from math, so from the math module, import, and then I can select just the one thing to import. The funny thing is, so just to be clear, if I import math and then I call math.square root, that's easy. Okay. If I say from math import square root and I try to run math.square root, it says math is not defined. And it's kind of confusing because it feels like line 36 kind of feels like I just imported math. But I didn't. I did not import the math module. I told Python to find the math module and take square root from the math module, importing only square root and nothing else, right? So what that means is when I go to use it, I can just use square root like that. You can do something kind of interesting here, where you can rename it. So I don't know if squirt sqrt is used for something else, or you don't want to call it that. You can say from math import square root as square root, right? So if I try to run this sqrt, it says sqrt is not defined. Kind of seems weird because it kind of seems like I just imported sqrt, but again, it's not quite what happened. So I imported sqrt and I called it square root. So square root is in scope, and it's sort of an alias for the sqrt method. Excuse me. Cool. So that'll work there. You can also do, I believe, if memory serves, import math as math. I don't know why we would do that, but I don't know. You know, why not? So we'll say math dot square root. So I could rename the module in the scope too. So you can use as to call the thing that you're importing. Give it a name of your choosing, and sometimes that can be helpful. One thing that we use a lot from math is e, and what I like to do, there's a constant e, so what I like to do, e, I like to just call it capital E, like this, and this, there are different conventions around this, but to me, E, excuse me, when I see a capitalized, an all caps variable name, or a single letter that's capital, I think of that as a constant. So there's a convention that I like to follow, and you don't have to follow it. It's just a convention that I like to follow. It's sort of a well-established convention that's sort of cross-language to capitalize constants, or not capitalize, but all caps, to do all uppercase constants, right? So if it's a single letter, a capital letter is a constant. So if I wanted to do E, oops, we could do E like that. So that's just something I like to do when I'm importing E. Sometimes I'll just import it and rename it as capital E like that. And then there's our constant E. We could do import pi as, let's see if I can, see if I get this one. Yeah, there's pi, right? That's pi? Yeah. So I could use, I have the Greek character pi here. I believe it's going to let me do this. Yeah, that'll do it. So if you have pi on your keyboard, you can name it actually pi, like the Greek character. Cool. So yeah, so you can see I can import multiple things from math like this. And I don't have to rename them. I could just keep things easy and just call it E and pi. That's, I think, what most people do, which is fine. I'm not sure, outside of code that, like only I'm going to use, I'm probably not going to like actually use like Greek letters in variable names if anybody else is ever going to have to deal with that code. But in my own code, so just be careful about that. It just occurred to me like, okay, I'm talking a lot about convention here, so I don't want people to get the sense that like, well, you have to use that character or something if you're using pi. So yeah, I think this is generally convention, is to not rename them, but you can if you want, which is kind of nice. Okay, cool. So that's all, that's all kind of covers some of the bases of various forms of importing. So you can see there's kind of a lot of forms. There's kind of a lot of forms that this could take. Let's do this. But the simplest, I think kind of the simplest one is just to import and then the module. And then all you got to do is remember that math.e and math.pi, right? All you have to do is remember to put the name of the module and then dot whatever property you're trying to access, whether it's a method or a property or whatever of that module. This might feel a little more clunky, but I recommend this way because it's very simple and it brings the whole thing into scope. Which, if you're importing a very, very large module, I don't know, maybe that might make a difference in your program's memory. But I don't know, my machine has 40 gigabytes of memory on it. And I mean, I think even a regular machine at this point, a regular computer, has at least 8, really. Even if you have less, like the math module, it's not even, I don't know how big it is. You think about like a big module is probably not more than a few dozen kilobytes, really. Maybe a megabyte or 2. I'm hazarding guesses here. I'm really guessing about that, but to be honest, these modules are not huge in the way of like they're not really the thing that's like making a giant memory footprint necessarily. It's not that you shouldn't be aware of that stuff, and again, it's not that I am like against optimizing code. It's good to optimize code. I like writing optimized code. I like optimization processes. But the way I think about it is the way most development or many development cycles kind of look is you have a problem, you do whatever to solve the problem, and then you ask yourself, am I up against a performance bottleneck? And if I am, to come back and reevaluate and see if you can improve things, right? So often in the sort of early stages of a project, I think it makes sense to just import the whole module, use it like this. Another reason I kind of like it is it makes it clear, like where in your code, where things are coming from, right? That this E is from the math module and that pi is from the math module. So, yeah, those are some of the reasons. And I think all of those reasons are good, particularly at kind of like supporting a beginner sort of learning arc, right? So if you're more of a beginner, just using this simple syntax, just remember to put the module name before the thing you're accessing. And then you have a simple, consistent tool that gives you kind of wide variety to easy access of things, or wide variety, excuse me, easy access to a wide variety of things within that module, right? So it gives me access to the whole module. So it's not only simple syntax, but it's a very straightforward paradigm. It's a very simple idea. So, and then it also makes it clear when you're using parts of that module that you imported. So if you need to go clean something up later, you can always just give your code. I think it's always good, after you solve a problem, to just do a sort of like a first tier optimization step to it, and just look at it and say, is there anything in here that's worth improving, that's either obvious or easy to improve, or is there anything in here that's like so egregiously poor performing that like it's probably really important to improve it. But yeah, like I said, I don't tend to think of like importing a whole module as being like an egregious use of RAM. It's just maybe you're using a little more than you need, but usually it doesn't matter. Okay, cool. So I'll leave that there. Good. So, I'm just kind of skimming through here. I think this is kind of telling you here the same things that I just went over. It's talking about importing math, and they're using the math.factorial function. Okay, cool. Let's just jump into the challenges. All right, so complete the function called Euclidean distance, or eucdist. This function calculates the Euclidean distance between the first list and the second list. The equation for computing Euclidean norm can be found here. Okay, we're off to go through that. Assume the two lists will be non-empty. Note, although you can take the square root using this syntax, x to the half, which is honestly, when I need to use square root, this is what I always do. So the square root function from math, the math module, is preferable and significantly faster. Cool. So yeah, like I said, this is what I do when I calculate square root, because I don't know, that's just what I usually do. But we have the actual square root function, so we'll use that. Cool. So let's just bring this into here, and this is going to be the same as the Code Wars problems. Okay, so we're going to import math. We'll keep it simple. We'll use math.square root in there. So I'm going to just write some lists, or excuse me, some tests before we really get started, and yeah, then we'll get into things. Cool. So I think what I need to do, we'll come here, Euclidean distance. Sorry, I've got dark reader on here. Let me turn this off. Okay. So in mathematics, the Euclidean distance between 2 points in Euclidean space is the length of a line segment between 2 points. It can be calculated from the Cartesian coordinates, which, let's see, we don't have example inputs. Okay. let's just see. I'll read through here and see if we can get a better idea. So calculate the Euclidean distance between 2 points. Each point is represented as a list. So a point is going to have an x, y coordinate. It can be assumed that the points will have the same number of dimensions. Okay, so x, y or x, y, z. So i.e. the lists will be of the same length. Okay. All right. So it can be calculated using the Cartesian coordinates of the points using the Pythagorean theorem, therefore occasionally being called the Pythagorean distance. These names come from the anti-Greek mathematician Euclid and Pythagoras, although okay. So I just want to get to the point where I get the formula. So I'm looking through these formulae, and I'm trying to get through. So I'm trying to see, since we have lists here, I'm looking at these. This D denotes the function, the distance function that we're going to implement, and P and Q are going to be our lists essentially. So I could even call this P and Q, but I'll call it list 1 and list 2 for this purpose. So real quick, I think what I want to do, I'm going to try to steal some tests here. Oops, I canceled them by accident. I'm going to try to steal some tests by just making this fail. And I always like to have an idea of what the tests are doing. Okay, so here's our Euc distance function, and this is the same thing. I'm going to do the same thing I did with Code Wars, right? So I'm just going to look for some invocation of my function, and I know that this assert equals is saying that so assert equals takes in 2 arguments, and they have to be equal. If they're not equal, it throws an assertion error, which means it fails the test, right? So this is going to be the first argument, and then this is going to be the second argument. So this this function should give us a result excuse me, a result of 0. So I'll just delete this. I'll say eucdist, this is going to be our res, equals that, and then 0.0, I don't really need to copy that, but 0.0 is going to be, oops, do this. This will be our exp, our expectation. It's going to be that, and then I'll print res equals exp and res. Okay, good. Okay. Just delete all the stuff that's not the thing we want. So let's see. Okay, cool. So what I'm doing here is I'm just kind of mining this for tests. So this gave me sort of an edge case, which is, you know, if the 2 lists are the same, I should get 0, because a point has 0 distance from itself, right? So if what I did is I just returned 0, 0 just to have it give me another test to fail, so I can do the same thing. And I'm going to just steal this test as well. Okay, so here's our res equals that, and then here's our exp equals this. There we go. Same deal. I'll just get rid of all that. Okay, cool. So this, I could probably do this like, I could probably do this again, but this gives me something to chew on. You know, this is, I've got 2 tests, so I feel like I can really start digging into this problem. So from here, I think it's just a matter of implementing this right here. So higher dimension. And I'm going to go with the higher dimension one because I know the lists will be, because the problem statement, you know, said, or the problem statement, or, oh yeah, right here, the lists will be of the same length. So I know this, I'm going to take this as true, because it's saying it, so I'll trust it. And what I don't know is how long they'll be, right? So I know they'll be the same length, but I don't know how I don't know what that length is. So we'll just see this as a higher dimensional one, right? So what this is saying is, let me just screen cap this. You probably won't be able to see my screen capture. That's okay. You can see it there anyways. Well, can you? That's a little small. Let me make sure. Okay, so d of q and p is the square root of p1 minus q1 squared plus p2 minus q2 squared, etc. Right? So I just need to I need to implement this p1 minus p1 minus q1 squared, and then increment the next to the next element, which will be p2 minus q2 squared, and then just add those all together, right? So this looks like an accumulator pattern to me. So I think I'll call this ACC equals 0 for accumulator, and we'll say for I'll zip them together, and I'll do P and Q. For P and Q in list, this will be list 1, list 2, zip list 1 and list 2. Oops. I don't like calling them P and Q. I don't like it. What should I call it? Maybe PI and QI. Yeah, that's better. I feel better about that. I like that better. Although PI is pi. Okay, fine. We'll do underscores. PI and QI. Okay, there we go. Cool. And then I'll say, from there, it's just a matter of implementing this bit. So that'll be PI minus QI squared. And just because parentheses are friends, right? Well, actually, they are necessary here, right? They're necessary here because this reads differently, right? This reads PI minus the square of QI, right? So QI squared is being subtracted from PI, and we don't want to do that. We want to do PI minus QI and then square that. Excuse me. And then I'll say ACC plus equals that, right? So that takes care of PI minus QI squared and the plus, right? So that's going to do all that. That does everything under the radicand symbol here, the square root symbol. It does everything except the square root. So when we return, we're going to, where I imported math, we're going to return math dot square root of ACC. Cool, so let's do that. And looks like I get 2 trues here. So that's passing my test. So what this means, well, hopefully it's obvious, but if it's not obvious what this means, it says true because my result is the result of my function. Res is the result of my function. And that's equal to my expectation, given these inputs. 1, 2, 3, and 1, 2, 3 should give me, for those inputs, I expect 0. And I'm saying res is equal to x, and that expression is true because my result is producing the same thing as my expectation. And then obviously I just print my result just to visually confirm, and then the same thing down here, right? 9.643, etc. is my expectation, and that's, you can see since I'm printing res, since I'm printing res as well, that's what I'm getting as well. Cool. Oh no. Okay. All right. Okay. Copy that. And hopefully, sorry, I know I had the text kind of small there. Need to go redo my settings for this browser. I don't think that'll help. Cool, that's correct. And let's see what their solution is. Looks like they used a range of the length of just one of the lists, and since we know they're of the same length, they could have used list 1 or list 2 here. It's just an arbitrary decision, so you just pick one. They're calling the sum underscore instead of ACC, but it's the same diff. And then diff is equal to list 1 sub I minus list 2 sub I, and this is what I'm calling PI and QI, right? And that just squares it, and this does that in 2 steps. But this would be the same if that was just in place of where diff is being used there. And then same thing down here, they just return the square root of the sum. Cool. Okay. We got 2 more. Awesome. So this is complete the combinations function. So this function takes 2 integers n and k and calculates the number of combinations in which k items can be chosen from n items, where the order doesn't matter. So this is actually a little bit redundant. Combination is always that we don't count different orderings of the same items, right? So if I was choosing A, B, and C is the same combination of letters as B, C, and A, and it's the same as B, A, and C, and it's the same as A, C, and B, and C, B, and A, and C, A, and B, right? So even though those are different permutations because the order changes, they are the same combination. We regard those as the same combination. Cool. So we'll go consult the old combinations function. So this says in choose. Can you see that? Oh, that's getting cut off. Sorry. Let's zoom into that. Cool. So here's our combinations formula. Okay, no, here, this is something different. I'm like, wait, what? So this is what I'm trying to highlight right here, actually, is this part. So it's in factorial over k factorial times n minus k factorial. So we can import the factorial function for this one. I'll comment this out here, and I'll come back here. I'll leave the problem statement in there. Okay, so I'm going to say import math, and I'll return. Now let's look at that again. Make sure that's actually going to be big enough and show up on yeah, so this right here. Just select that so you can see it. So actually I wish I could. That doesn't show up very well. That's okay. It makes it clear at least. Okay, so n factorial over k factorial times n minus k factorial. So I'm just going to return math dot factorial n over math dot factorial k times math dot factorial n minus k. Now, one thing I want to point out, I'm actually glad I caught this. I kept making this mistake over and over. You do need the parentheses on this second term because order of operations will make this happen in a different way. Now, I want, this is a good opportunity to kind of develop a paradigm here. So right now I could have a conversation about order of operations and like how to think through order of operations and work it out every time, or I could just tell you to just commit to using a lot of parentheses. Think about, rather than thinking about the order of operations, how it's going to happen if you don't use parentheses, if you just leave things alone, how is it going to happen on its own? Just think about the order that you want it to happen and use parentheses to make that order happen, right? So think about, so it's sort of like, rather than going, oh, what's it going to do, and let me make sure that it's going to do that's going to line up with what I need it to do, and if it doesn't, then I'll use parentheses, right? Rather than that, just assume it's not going to do what you want it to do. Just always assume that the order of operations is going to stab you in the back, that it's going to evaluate in an order that you don't want. So think about the order that you do want, right? I know this is the whole entire upper term, and this is the whole entire lower term. So since there's literally only one part to this, I mean, I could put parentheses around it, although that feels silly. There's literally one part to this. This is one thing, and I need to put parentheses around that. But since there's an operation happening here, just put parentheses around it. Now, in this case, the parentheses are necessary. But even if they weren't, I would encourage you, like as a good habit, as a default, it's better that you guarantee you get the right result and have maybe a couple more parentheses pairs than you need, than it is to like, strive for ultra perfect clean code and be a little uncertain as to whether it's happening in the way that you want it to. So, just for the sake of consistency of execution, making sure that your code's going to do what you want it to do, if you want to lean in the safe direction, just assume that you need parentheses, right? So another way of looking at this, like if this was, this is no longer a combinations function. But if this was an operation that wouldn't take precedence, right? So if we follow order of operations, it's PEM, D for division, and then A for subtract or for addition, right? PEM, DAS, PEMDAS, or at least that's the order of operations how I was taught it. So division takes precedence over addition. So in this case, I don't need parentheses, but since I know that this whole thing is the thing that I want to be the lower term, just throw some parentheses around it, right? Like better safe than sorry. That's so. It is sort of like it's founded on that opinion, and if you want to do something else, you're free to do so, of course, but you know, be forewarned, might cause other issues. Cool. Yeah. I ran it expecting tests to run, but I didn't write any tests. So let's just jump in here and do it. So let's try that out. Okay, I did something wrong. Sorry. Okay. Math is not defined. It was like kind of the whole point of this thing is to import something, whatever. Okay, so if I actually put in all the code, then it did work. Cool. They're taking an extra step here. I just want to point this out. I forgot to do it this time, but usually actually we'll do this. So combinations will only ever return, I mean, given that you give it integers on its input. Let me just, it'll be easier to show this. So if I have 10 elements and I want to see how many combinations of 2 elements I can make. Okay, I can make 45 combinations of 2 elements. Okay, so the way it's written, since I'm using this single slash division, yeah, I could use floor division there. Since I'm using this single slash division, it's always going to yield a float. So notice both of the inputs are integers, and the single slash division always yields a float, even if both of its inputs are integers. In this case, you might say, oh, well, maybe factorial is giving out a float. Factorial won't give out a float. It'll just give it out an integer as well. So the thing is, combinations, given that its inputs are integers, which they should be, or at least they should be whole numbers, right? Given that its inputs are whole numbers, combinations will only ever yield a whole number. This will always result in a whole number. So, given that, it kind of just makes sense to just cast it as an int. And you might think, well, you know, if you're going to get the same result from floor division, right? If that's going to give me an int, right? Well, what if I did this? What if I passed in 2.0? Right? Oh, wow. Okay, fine. Just prove me wrong. Oh, actually, that kind of makes sense. Because these factorials are always going to return integers. Okay, yeah, that's true. So this would actually work because factorial is going to kind of be a safety between that. Still, though, my personal preference and my habit is when I want something to return an integer from a division operation, I use regular division, a regular single slash division operator, and then if I want that to yield an integer, I just cast it as an integer. I just put the whole thing in an int function, and it's always going to give me an integer. So I guess I don't need to do that this time. I still feel better doing it because A, it's consistent with the way that I do things, and B, it's more explicit. And I think that's really the argument that I have for me doing it that way is it's always nice to have code that's clear, right? So what this is saying is I'm declaring that whatever happens in here, even though whatever happens in here, if I do floor division, will always give me an integer. I'm declaring, that whatever happens in there, I am making it an integer. I explicitly am committing to and know that I want an integer out no matter what, right? So, yeah, that's why I kind of like to do things that way. But yeah, you can do something else if you want to. Cool. Let's see. I do want to kind of chase that example down though, real quick. So if I do, let's do 10 over 2. That'll give me a float of 5. If I do 10 floor divided by 2, that'll give me a float of, or an int of 5. But if I put a float into floor division, and it doesn't matter which one, right? Like the data type out is still a float. So it's only when both of the inputs are integers do you get an integer, right? So to me, like I said, this is more consistent, right? Because regardless of whether either one or both of these are floats, the result will always be an integer, right? So when you use floor division, the data type returned is dependent on the data type inputted. But when you cast regular division as an int, the data type returned is always an int regardless of whether the inputs are also ints. So it's not dependent, its output type is not dependent on its input type. And you might think, who cares if you get a whole number float or an integer, right? Like it might seem like a trivial difference. I mean, if you're just using it for its value in a mathematical formula, it doesn't matter. But if you're using it as an index, it does matter. And I'm not sure I really use the output of a combinations function as an index that much. I may have in the past. I don't remember. But to me, it's just like, okay, there is a difference. There are times when, the value 4.0 is not going to do what you need it to do, but the value 4 is, even though they're the same numeric value. That data type can matter in certain circumstances. So if I have anything that I am certain, if I use it correctly, if I use it within the bounds of how it should be used and how it should be correctly used, i.e., if I pass it the correct inputs, if I did enough to at least pass it the correct inputs, and I have something that I know is always going to give me a whole number value, right away in my head I'm like, I should just cast this as an int just in case I ever need the limitations or the well, it's funny, it's like an integer is has more limited values than a float, but because of that, it kind of has wider application, right? So if I ever need to use it as an index, casting it as an int just makes sense to do in the function. So that's why that whole thing. Okay, cool. That was fun. All right. Cool. Well, we're running close to time. We have another challenge in here. I think I'm going to save it for next time. It's Friday, so I think I'm going to opt into quitting 7 minutes early or 6 minutes early and taking a slightly early day. But yeah, it's been fun. I hope people find this useful. Let me know. I decided to kind of on the fly. Before I started today, I was kind of debating, should I do Code Wars or should I do our Galvanize Learn material stream? And I kind of at the last minute, I was kind of indecisive, and then in the middle, I'm like, oh, I want to switch. So yeah, if you're watching this stream later, let me know which one, if you want to see more of one or the other, or if you like the format, if you like kind of mixing it up. I'm kind of having fun just experimenting with different things in this stream at the moment. I want to kind of branch out and maybe do some specialty topics. If you have a request for a specialty topic like environment setup stuff, yeah, feel free to send me a direct message and mention it, and I'll consider it. I'm happy to take suggestions and requests and open to suggestions on this. So yep, I hope you enjoy it. Hope you find it useful. Do feel free to reach out to me. I'm available for one-on-one mentoring if you want that. There's a lot of other people on my team that are available for that as well. So feel free to reach out. Don't be a stranger if you just want to say hi. And I'll get back to you as soon as I can. And if you need help with anything, I'll be happy to help you or point you at somebody that can answer your questions and help you out. Cool. Yeah. So it's been fun. I'll wrap up here, and you'll have a good rest of your evening. Bye-bye.